All right, I think that's my cue to get started. Hi, everybody. Hi. So this is the talk on Kubernetes security best practices. So this talk is going to be a little bit about what sort of simple things and hopefully easy things you can do to help make your Kubernetes cluster more secure. My name is Ian Lewis. I work for Google as part of Google Cloud, and I'm based in Tokyo, Japan. I focus mostly on Kubernetes and Google Container Engine, and also on container security related features. So I'd like to think about Kubernetes in terms of what type of piece of software it is. So most people call it a container orchestrator, but I like to think of it as something like a framework, or basically something that provides infrastructure. In the form of an API, and as part of that, it provides features, and many of these features are security-related features that you can take advantage of in order to make your applications and your infrastructure more secure. So in terms of topics and the agenda for the talk today, I think with container and Kubernetes security-related topics, you could probably talk for an entire day. So I don't think I have time for that. But what I am going to do is I'm going to cover these topics. So I'm going to do a little bit of Security 101, just give a little bit of background. We'll talk a little bit about runtime security and host security, as well as network security, and provide some tips on how to make those a little bit more secure. There's obviously many other type of topics related to container and Kubernetes security, like threat detection, determining if you've been compromised, making sure that your build CI/CD pipelines are secure, making your images more secure, how to do security operations. Those are kind of topics that I'm not going to be able to cover in this talk, but hopefully you'll get some things that you can take home and do tomorrow to improve the security of your cluster. So just for some background, some Security 101. I just want to get everybody on the same level to understand the background for what we're trying to do here. So basically, security, the first thing that I want everybody to understand is that security is not something that is just a linear thing. It's not a single scale where you make one thing, you make your entire cluster more secure or whatever. There's many different pieces of a Kubernetes cluster and many different pieces of all kinds of software. And so each of those has its own security posture or security context. And so you need to think of it as a holistic picture. Another thing that we need to understand is that attackers can pick their targets. So this is basically part of the idea that there's an attacker's advantage to security. So this is, usually people say something like attacker's advantage, defender's dilemma. So essentially that means that attackers have an advantage over defenders when you are thinking about security related to software. So basically attackers can pick which things they attack. They can pick the time that they attack. So they can pick a time in the middle of the night when you're sleeping in order to attack your cluster so that you won't notice, things like that. And so these are things that you have to think about as you are doing the security of your cluster. And attackers can attack whichever thing is the weakest link in your cluster. So you need to make sure that the holistic picture of the security of your cluster is thought about and is addressed. So part of how you do that is by applying something called layered defense or defense in depth. So this means that you make each of your security pieces of security are redundant in your cluster. So this means that an attacker has to do multiple things in order to get data that's interesting. So get user data or credit cards or anything like that that is important to them. Most programmers are familiar with the idea that you don't want to repeat yourself. You don't want to have multiple copies of the same code in your code base or something like that. Whereas security is very much the opposite. We want to be redundant. We want to make sure that we have multiple things that we're doing in order to secure something. We also want to limit the attack surface at each piece of these levels. So what that means is that we want to give the attacker as few options as possible in order to attack a cluster. So this means, usually this means reducing the amount of software that's installed on the machine or inside of your images, inside of each of your applications, so that there's less software that you have to patch, less software that is vulnerable to attack. And then finally, the last concept that I want to talk about is the concept of least privilege. So this is the idea of providing each of the applications that you are running with the least amount of privilege that it needs in order to run. And this is so that if somebody is able to take the credentials of that application, they don't get more permissions than are absolutely necessary, because that means that they could then further their attack or get more information and then escalate their privileges and then cause a wider and wider problem. So today, this is an application that I'm going to be using as my kind of example application as I'm talking about the different security ideas. And this is just a guestbook application that has a few different services here. So we have a web front end, which is just a web service. And that web service, the users can post a guestbook message that gets saved using the message service to a Redis database. And we also have an authentication service called the user service. You don't really have to think about this too much. This is just an example application that I'm going to be using as we talk about the different security-related problems and things we can improve. So I'm going to talk about a few different ways of attacking a cluster, and then try to talk about some of the ways that we might mitigate those problems. So the first thing I want to talk about is attacking the kind of Kubernetes cluster itself, or the API server itself. So by default, every pod in a Kubernetes cluster gets what's called a service account. And particularly if you're not using RBAC, each of those accounts, or those service accounts, has a number of permissions or a role associated with it that allows that pod to talk to the API server and make requests to the API server. And if you're not careful and you have given too many permissions to this particular service account, you can use that service account to then do things with the API server, like send requests there. So we can imagine that our web front end has some vulnerability in it that allows us to read a file off of the file system. And so what this does is would allow the attacker to read a token file that then the attacker could then use to send a request to the API server with that token, and then be able to perhaps create pods, maybe read some secrets, that sort of thing. And so what we want to is kind of be able to prevent those type of attacks and mitigate them. So the first thing that you absolutely positively need to do is make sure that you are using RBAC in Kubernetes. This is the default since I think about 1.4 or 1.6, something like that. So it's been the default for a while, but it's still possible to disable it if you don't know what it is. So this is something that you absolutely positively must be using if you want to have a secure cluster. And what this does is it gives roles to each of the users in your cluster, as well as each of the service accounts that are running in your cluster. So this is the service account that gets added to your pod. And then each role in RBAC contains a number of permissions that the user or the service account can perform. So this is usually a verb and a noun. So something like get secrets or update config map. These are things that a user can do. And then those roles can be assigned to people. So you can assign the same role to multiple people, and each of those roles can have multiple permissions. And then another thing of note is that RBAC settings apply to namespaces, so that if you can assign roles to a user that are allowed in one namespace but not in other namespaces. So roles look something like this. So in this case, we have a cluster role and a cluster role binding. And what this is doing is just assigning a role to a user. And each user can have many roles associated with them. And in this case, we're applying a role that applies to the entire cluster. But if you use just a role or a role binding, that applies to a single namespace. So that's going to allow us to mitigate allow the API server to decide whether we can perform certain types of operations. Another thing that we can do is that we can firewall the API server so that the attacker hopefully does not have access to actually even send a connect to the API server from, say, the internet. So we can do this using regular firewalling rules or port firewalling rules. Or if you're using something like GKE, you can use a master authorized networks feature in order to limit the IP addresses that can access the API server. Another way to mitigate further attacks on the cluster is to use something like network policy, which allows us to if we look back, we're saying that an attacker could then continue to read secrets and then attack other parts of the cluster. So things like network policy can help to restrict the things that you can have access to from a single pod. So if you have, say, our front end doesn't talk directly to Redis, but we want it to talk to the message server instead, we can set up network policy to make sure that our front end is not able to send requests to the Redis server directly. And network policy is used, has an implementation, which is usually Calico or Weave or some other network policy enforcement mechanism. And it looks something like this, where you specify a label selector to tell which pods that the policy applies to, and then which pods that pod is able to accept requests to or send requests to. So in this case, what we're doing is we're saying that this applies to our Redis pod and that we are going to accept ingress. So incoming network requests can only come from our guestbook or our message application and not from the web front end. Another way that we can, another problem that is typically happens in clusters and is a way that somebody can attack a cluster is to get access to cluster components and manipulate those cluster components. So one typical thing is to just, if you've provided your Exedy that the API server uses to the cluster, then an attacker could interact with Exedy and bypass the API server completely. So you need to make sure that your Exedy is secured. So the things that you would need to do is to make sure that your Exedy is set up so that it requires authentication, and then firewall it to make sure that you cannot send network traffic to Exedy from inside of the cluster. This just makes it so that your cluster objects, the things that the API server saves in Exedy are secure, because if a user is able to modify those objects directly in Exedy, that's the same thing as if they had full access to the entire cluster. They can create pods or they can read secrets and things like that. And so we don't want them to be able to do that. Another thing that you can do is you can encrypt the data that gets saved into Exedy. So the API server has the ability to encrypt data that's coming in and being saved to Exedy. So this allows you to make it so that if somebody tries to read from Exedy directly, they're just reading encrypted data and they're not reading data that's just basically saved in plain text. Another way that you might attack a cluster would be to break out of the container and then try to get access to the host itself. So this is a single worker node in the Kubernetes cluster. And then read data off of other containers or the configuration of the kubelet in order to further attack the cluster and get escalated privileges. So typically people will break out of a container by using something like a kernel bug or some other container or some other Kubernetes bug. There have been several that allow container escapes. And so a user or an attacker might be able to break out of a container and then read files from the file system or otherwise execute applications on the host outside of the container. And so this would allow them to read and see other containers that are running on the host, read the secrets that are associated with those containers and whatnot, as well as be able to read the kubelet's authentication and certificates. So what then users can do, and attackers can do is use those credentials from the kubelet in order to talk to the API server and pretend it's the kubelet, and then try to get more information about other pods or other secrets. So one thing to do this, to try to mitigate this, is to try to make it harder for people to break out of a container. So one way to do that is to run applications inside the container as a user rather than as a root user. Typically in Docker, people run applications as root inside the container, and this just makes it one step easier for folks to be able to break out of containers, and so it's much better practice to run them as a user. Typically, to break out of a container, they have to first get privileges as root inside of the container in order to break out of the container. So first step is or the first kind of low-hanging fruit is to run your applications as a user inside the container. Another good practice is to make your root file system read-only for your application. So sometimes applications require you to write some data to disk or to the file system. So you can either create a temporary directory or an external volume that you can allow the container to write to. But the root file system itself, you can make that read-only. And this prevents applications or attackers from overwriting files on the file system that you don't expect them to be able to write to. So maybe your application allows you to upload files, and you have a bug in the application that allows them to upload a file to anywhere. And so that makes it so that they can overwrite some binary and then trick your application into executing that binary, and then they have full privileges inside the container. So this just helps you, is one way of trying to prevent that type of attack. Another thing to do is to not allow new privileges or set the new privileges flag on your application. And this just makes it so that if your application is executing another binary, that you don't allow extra privileges to be attached to that particular application or that particular process. So this makes it so that it's harder to escalate privileges inside of the container. And if you do these all together, then that just makes it even harder for application or attackers to get privileges inside the container that they can then use to break out of the container. Another idea is to use Sandbox Pods, and this is using basically a different runtime from the normal container runtimes in Kubernetes. And what these do is they give you an extra layer of isolation between the sandbox or between the container and the host system that allows you to run applications that you don't trust as much. So typically these might be used for something where users upload code or where you're executing third-party applications. And so things like Kata containers or gvisor are solutions for that that make it really hard to break out of a container. So gvisor looks something like this, where we have it intercepts syscalls and handles that in the in user space rather than using the host. And so that makes it really hard to take advantage of bugs that are in the host operating system in order to break out of the container. Another way to further lock down a container is to use seccomp, AppArmor, and/or SELinux. So a container, if you think of a container like a jail for your application, it's a little bit leaky in the sense that you can do a lot of things. There's a large surface area that you can attack. But seccomp then allows us to add another kind of like layer on top of that container isolation layer. And then AppArmor and SELinux allow us to add another layer on top of that adds other policy, more policy, and more options in order to kind of further lock down the container and make it hard to escape. So one thing that I really recommend that people do is to enable seccomp, the runtime default seccomp policy on their containers. And this is like woefully still not applied by default. And so what this does is just applies the default Docker runtime or seccomp policy to a container. So at the very minimum, you should be doing something like this. You can also use AppArmor, which thankfully, if it's installed, will apply the default AppArmor policy to your containers. But if you need to develop your own profile, or you want to really make sure that you're running AppArmor using an AppArmor policy, then you can specify that as an annotation in your pod as well. And then SELinux is still the only one that is currently GA as a feature, and that's part of the security context. So inside there, you can specify SELinux options in order to specify the type of options that you want to use to lock down the container. The downside of all of these is that it kind of requires that you know what your application does in order to be able to specify the right types of options in order to lock down the container properly. And then after they've broken out of the container, we can try to mitigate things like them reading your kubelet credentials and then being able to do other things in the cluster by using RBAC for the kubelet, which is enabled by adding some options to your kubelet or to your API server. And this gives or creates a special RBAC role for a node that restricts things like reading secrets on the node to only to secrets that are attached to pods that are assigned to that node, for instance. So a node can't just read any secret in the cluster. It can only read the secrets that it's allowed to see. And so this kind of limits a little bit what you can see from the node. Another thing to do is to rotate those certificates so that even if that certificate is stolen, it's only valid for a short period of time before it becomes invalid. Another thing that's an issue is unsecured pods. So this is basically if you create a pod, I showed you a bunch of options that you can set in order to make pods more secure. But if you have many, many people using your cluster and you want to make sure that everybody is like doing the right thing and setting all the features that they need to on their pods, you want to be able to set some sort of policy that says you can't create pods without that run as root, for instance. So you can use something like Open Policy Agent. Excuse me. In order to block those type of features by creating some policy that specifies the type of policy that you want to use, and then basically uses the admission controller features of the API server in order to block those type of pods from being created. So this is something to investigate if you want to kind of help secure a cluster against multiple teams that are using it. And then finally, I want to talk a little bit about listening to the traffic that goes between the services and doing things like request forgery. So this means like sending a request to another service as if you were, as if you were a different service and not the one that you are. So in this case, we're sending direct requests directly to Redis instead of from the message service. And we can mitigate that by using things like Istio or other service meshes that provide a identification or an authentication mechanism for your services so that you know which service is sending the request and which service is receiving the request, and you can block services that are not being used or that are not allowed to access it. So this is very similar to the way that network policy works, except it works at a service level rather than at a network level. So it's another way of adding that kind of defense in depth. So what Istio does is it puts a proxy between services and then enforces service policy that way. And then it encrypts traffic between the services and roles. It continually updates the certificates so that they aren't valid forever. And this will allow you to do things like if the web front end tries to send, much like network policy, if the web front end tries to send requests to services that it's not allowed to send requests to, then those requests will be blocked by the proxy on the other end of the request. You also can't just listen to data or traffic on the network that your cluster is running, because all of the pods will be sending all of the encrypted traffic. All the traffic is encrypted between the services, and so listening to traffic on the network means that you're just listening to encrypted data or encrypted traffic on the network. So this just helps secure your cluster overall in case it's been compromised. So I'll just finish up by giving a few extra tips, some general tips. One is to update your Kubernetes cluster early and often. So often Kubernetes itself has some security issues with it, and so you want to make sure that you're using the latest and greatest Kubernetes. And make sure that your node obviously has up-to-date features as well, or up-to-date applications. Don't use admin privileges for your everything in your cluster. Use admin to say deploy applications only from your CI/CD or your say Jenkins or your deployment server. Don't use admin from your say laptop, because maybe if you lose your laptop, you don't want to have somebody be able to access your Kubernetes cluster and be able to use admin privileges. Try using things like benchmarking tools such as KubeBench, and which will inspect your Kubernetes cluster and give you suggestions on how to secure it better. And also use things like managed services like GKE, which will give you a little bit better defaults and better, they're not perfect, of course, but they'll give you a little bit better defaults in terms of your security posture just by using the service. All right, so that's all that I had time for. Hopefully that was useful to you guys. I don't think I'll have too much time for questions up here, but I'll be hanging around outside, and if you have any questions, you can grab me and we can chat. Thanks a lot.